Hi there, this is a brief video that outlines the progression of units from 1, 2, and 3-dimensional measurements. So without any further ado, I suppose we should title this measurement. Wow, that's an interesting pen. I think I'll change that. Let's come over here and choose purple because purple is the most superior color. Let's just talk real quick about what it looks like when we are measuring an object in one-dimensional space. So we're going to call this one dimension. There is only left and right. There is not up and down. There is not in and out. We call this shape a line. And this line has a finite length. We're going to measure that in one-dimensional units. And just so that we can be clear, we'll use a unit that's usually used for length, like centimeters. And we'll say that this thing is 50, well, just to make our lives easier, we will say that this thing is 4 centimeters. In one dimension, our units, centimeters, have one-dimensional power. So centimeters to the first power is still just centimeters, and we write it just like this. This is all well and good. Measuring one-dimensional distance is not too hard. For a lot of us, we learn about this in primary grades and number lines and so on. Let's move on to another dimensional space. We're going to add the up and down directions. And we're going to make a shape that is now two-dimensional, such as this square. Now, I know this may not be exactly a perfect square. We're going to assume it is, and I won't diagram it in a fancy way. But now we've moved to a two-dimensional shape. In this case, if we want to measure the total space of this two-dimensional shape, the idea is to measure what we call area. How much stuff, how much space is inside of here. Area is a different idea than just distance. Distance is a one-dimensional idea. We can call this distance. Whereas area is a two-dimensional idea. Call this area. Area requires two one-dimensional measurements. So in this case, let's use 4 centimeters here and 4 centimeters for this side. And assuming that this is a square, all of the sides would have the same length. And the area is going to be 4 centimeters times 4 centimeters, which is 16. That's our 4 times 4. And centimeters times centimeters is a little strange. We're going to call that centimeters squared. When you multiply something by itself, you get squared, right? So this is, you could say 4 squared centimeters squared. And that's an area idea. It's two-dimensional, second-dimensional measurement of space, of how much stuff is in this space right here in 2 dimensions. All right, what happens if we want to go 3-dimensional? Well, it turns out we'll keep using the square idea because this is easier to understand. So I'm going to draw a 3-dimensional version of a square, which we call a cube. I'm going to do it just kind of like this. Maybe we'll go this way so we have a little more space to talk about. We're going to pretend this is a perfect cube. Of course, it's not perfect, but you get the idea of what it's supposed to be. There we go. And each dimension of this cube is going to have the same length. So the height will be 4 centimeters, the width will be 4 centimeters, and the depth will be 4 centimeters. Now we want to measure the amount of space that is taken up by this cube if it were solid, for example. And now we are going to a 3-dimensional measurement of space. We call this volume. And likewise, with the 2-dimensional shape, we're going to take each of the dimensions for a cube anyway, and we're going to multiply them together. 4 centimeters times 4 centimeters times 4 centimeters. 4 times 4 times 4 is 64. And centimeters times centimeters times centimeters is centimeters cubed. So the idea here, as with this progression of units, is that in one dimension, our units are one-dimensional units, measuring a straight line or our distance. In 2 dimensions, our idea of all the space is called area and has a second dimensional unit, centimeters squared. In 3 dimensions, we're measuring volume, which is a 3-dimensional space, and our units are going to be third-dimensional units, or centimeters cubed. This works for any unit. If you wanted to measure this in inches, a 3-dimensional inches unit would be inches cubed. With one student, I measured it in pickles. A third-dimensional pickles measurement would be pickles cubed. How many cubic pickles makes up a 3-dimensional space? So with this in mind, hopefully this can give you a better idea of the progression of units in our different dimensional measurements. So a quick example here is if we draw, say, a cylinder, and I'm going to draw kind of a really rough cylinder shape. We'll just imagine that this is kind of a Campbell's soup can. It's good, right? So here's my Campbell's soup can. And let's imagine that we know the area of this circle, is 5 centimeters. And what are our units, since this is 2-dimensional measurement of space? It's going to have to be a second-dimensional unit, so 5 centimeters squared. We also know the length, this is a 1-dimensional idea, the length of this side of the can is 5 centimeters. This is a 1-dimensional unit, right? We can put the 1 there. I want to know the volume of this can. Well, you can kind of imagine that we're taking that circle on the top there. Let's imagine this circle, and we're kind of moving it down as a cross section all the way down the can, 5 centimeters down, to get a 3-dimensional measurement of volume. And so the formula for the area of a cylinder is just multiplying the area of that circle times how far that circle needs to be kind of pulled down. So the volume is going to end up being 5 centimeters squared times 5 centimeters, which gives us 25. Now we're talking about a third-dimensional space or third-dimensional measurement of volume. So 25 cubic centimeters.